Hello, SolarLune here. How's everybody doing in chat? But yes, hello, I am SolarLune. Actually, hold on. Oh, I think, hold on, give me a second. Okay, let me just move my chat over to the other screen. There we go. But yes, hello, SolarLune here. I'm an independent game developer and musician and stuff like that, and I'm the creator of Master Plan and also Tetra3D. So, hi. But yes, I will be working on a game in Tetra today, and or working on a project in Tetra, and basically in the process, working on Tetra itself. But yes, how's everyone? How's everyone doing? Sup? Hello, Vadim. How are you doing today? Music boy, J boy? Question marks. How are you both doing as well? Um, and just before I forget, if you want to support development on Tetra or Master Plan or anything like that, please check out the links in my description to Patreon and Itch and Steam and stuff. But yes, so Tetra3D is a 3D hybrid software hardware renderer that I'm working on. Still quite a ways to go, but it's doing okay. I this is kind of crazy because basically what I added recently, I kind of showed it a little bit in the previous video, but essentially I added a shader system. So you can, for example, write code that alters the vertex shaders. First, the vertex shaders for objects, basically by applying them to materials. So, for example, in this game that or a little demo or example I'm working on, which is a 3D scene where you can walk around and interact with stuff. Um, the player has a material. The ground has a material. This clock has a material. This bookshelf has a material. So what we can do is uncomment this code, and this will basically run this function for each vertex that is clipped. So in the process of making a 3D render, or in the process of rendering a 3D object, you have a 3D object, right? And its vertices are in local vertex space. And then basically they get transformed according to the rotation of the model, or if they're animated by an armature or whatever. And then when they're done with that transformation, they get clipped. They get transformed to clip space, which means that they're basically being rendered from like -1 to 1 on the screen, like in a square. So we have a program we can run on the clip space of the material. So basically this will do what actually this will make the character kind of wavy, kind of like he's like a jelly or something. Cool little effect. It might be good if we up the rendering also, a little bit smaller, up the rendering size, the resolution, so you can kind of see what's going on better. It might not be as pronounced, but you might still be able to see it. Yeah, it's a little light. Let's see if we can make it a little bit more pronounced, so you can kind of see what's going on. Yeah, so you can see here he's waving back and forth. So basically and it's not really taking that much frame time either, which is nice. So you can see as he moves, he's like wobbling, which is very interesting. But yeah, you can do a lot with this kind of a little kind of a simplified shader system. It's not nearly as fast as like OpenGL or Vulkan or something on your graphics card. If everything was handled through the graphics card, but it is kind of cool because you can access variables that don't exist in your, like, that you wouldn't be able to normally upload to a GPU. So that's an upside, is you have access to just like arbitrary variables. So if you wanted to make a shader that like read weather data, and you didn't want to have to like encode that in some way to send it to a GPU through a fragment or vertex shader normally, you could do it here by just literally passing just making accessible the vertex or the weather data pointer, and then you can just access it in the vertex shader, which is kind of crazy. It's an interesting idea. Anyway, so this currently is for clip and vertex. Like you have both vertex program as well as clip program, and then I'll make a fragment shader that operates on the. Yeah, I'll make a fragment shader at some point. I haven't done that yet. I don't need that. I don't think just yet. But we probably will make that happen at some point. And then the effect that I was showing off a little bit in the video, we can kind of localize to a single object, in this case the player, by doing something like this. I believe this should work. Or actually maybe be like this. Let's make this a little easier to deal with. Excuse me. Yeah, so this is a little bit more like a PlayStation 1 in terms of it locking the clip position of triangles to specific locations like a grid. But we can do this even more aggressively to get the effect that we had, or that I had in the previous video, where yeah, it's just kind of like it's kind of we'll go with maybe 25. It's kind of what's the word? It's like he's kind of like disassociating. Like he's not. It's still 3D, but he's not really like there. He's not really fully. He doesn't look like he's all there. I like that effect. I think that's very cool, and I haven't really seen something like this before in a game. It's the kind of thing where people would be like, "Are you rendering this to a texture, or like how are you doing this?" And it's like, I don't really even know. I'm locking the clip coordinates, but it's a very interesting technique and look. It kind of like breaks down the concept of like what 3D is. It's kind of like, you kind of get used to 3D stuff, and then when you look at something like this, it's like, oh yeah, it's literally just triangles. Like it actually is just triangles. And it's like this is no less 3D than anything else. This is no more 3D than anything else. Everything is just triangles. It's interesting. Anyway, so yeah, that's cool. That's very cool. Let's go back to the previous thing. The question marks says that's really neat. Thank you. Yeah, I think it's a pretty cool effect. It'll be very, very cool. I think I'm going to do that for something in the game. So this is working pretty well. I'm pretty satisfied with this. I believe the gamepad also works. Working with the gamepad also works fine, which is perfect. Let's see. Oh yeah, that's what I wanted to talk about. So I basically just cribbed my script system from another project that I was kind of messing around with. And that this system is essentially a what's the word? It's just normal code, normal Golang code. But the cool thing is that it's essentially running a Go routine as though it's a coroutine where it can be kind of like paused and stopped at will. So for example, here's it. Like I'm not doing it the way I did it with I Know Who I Am, where with I Know Who I Am, which is a previous project of mine. It was like I had to make a scripting language where I made functions that returned objects that would like, pause the game for, a second, like wait for, a second or whatever, or display a message or make the screen flash. And that was kind of the only way to do it. Here, I'm just accessing, objects or doing things like I normally would. Like there's no additional scripting layer on this where I have to like add functions to make the game work, or to make it possible to like display messages or anything like that. Instead, the coroutine system essentially allows me to go ahead and like pause execution of let me think about how I want to say this. It allows me to basically pause execution of the coroutine at will, but it's still running as an ordinary Go code. So for example, I can say, let's wait for time.second. So this message will display, this bookshelf has a lot of books I had never seen before. Then I'll wait a second, or the game will wait a second, and then this message will display. So that's cool because that allows me to make make a scripting system, but it doesn't make me have to like actually make the scripting language. It's ordinary Go code. It just works. Like that's beautiful. That's exactly what I wanted, and that's something that like Godot I couldn't really get working because the scripting language just didn't have that like that oomph, that little bit of control over yielding and stuff that I really wanted. In this, it works basically by having channels, using channels to indicate when an event should pause and let the engine run. Like like if you go and communicate with or interact with an event, the main engine code, like trying to think of what exactly is happening. Okay, so you go to interact with an NPC, the game pauses, and that is done by setting globals.cinematic to be true, which is just a normal variable. But when this is true, the player can't move and he can't interact with things anymore. So basically he's locked in place. Then, which is, you may not want this to happen. Like you might have an event where maybe it's just a timer, right? Like let's say you have some kind of like, you have to complete this, task in a minute. So you might have a timer that displays on screen, and then this event is running, but you don't want the player to be paused. You don't want him to be locked in place. So he can still move around, but the timer's running. So you might not want the cinematic to be true. But basically, the way it's just kind of weird. But the way this works, just to kind of dumb it down to the simplest possible explanation, there's channels in an event that indicate when the event should pause and when the event should execute. By blocking the channel, we can essentially pause the script at a certain point. So if we go and say event.wait, we can see basically if the time has exceeded the wait time. So it says, wait start, time is time.now. And then we basically loop in this go routine. We're looping until we waited enough time. And if not, then we're yielding. And yield is basically just sending data on a yield channel, which means basically and then waiting for a receiving event on the continue channel. So basically we send something on the continue channel when the game engine is like, it updated everything for a frame. We send it on the continue channel, and then when the event needs to yield, it will basically send something on the yield channel. So by blocking the yield and continue and done channels, we can tell when an event needs to execute, as well as control the game, control event flow. So this is it's kind of complicated, but the upside of this is it's ordinary Go code. It's ordinary, it's an ordinary system, but by really controlling these channels and having them work a certain way, and also making sure that they don't have race conditions or anything like that, the upside is you end up with this really powerful scripting language that's just ordinary code. So yeah, that was complicated, sorry, but and I definitely did not explain it as well as I could have. And if someone wants to ask for information later, please feel free to do so. I can make a video on it that's more prepared and kind of answer questions more accurately. But the upside is basically, the downside is the scripts are stored directly in the code, but the upside is it's just using Go. We're not using like Lua or an additional scripting layer, or we don't have to make functions ourselves and like tweak those functions. It's just ordinary code, ordinary Go, which is great. I'm gonna go ahead and make some play some music. Let's go with this. This is fine, I guess. There we go. Yeah, so yeah, go excuse me, go making multi-threading easy is great. Go allowing you to like block on channels is really useful, because that allows you to basically make something that yields in execution of a function, while also yielding like also being like interactable by just like sending data down a channel that is blocking, or receiving data from the channel that is blocking, to essentially like pull the block out of you know, something that's moving. It's very good. It's a little weird. Like it takes you know, some time to kind of get used to channels, for me at least, because I don't use them very much. But the upside is just like it works. But like if we wanted to, for example, move the player, let's say we wanted to move the player for like some, like move him around, we could probably do it by doing something like trying to think of how I want to do this, or basically where I would do this, how I would do this, because if we wanted to move the player and like have him actually walk, we have to alter his movement vector. So we'll do that. At least we'll try to do that. Let's see. Yeah, let's try this. Game objects. I don't have the function to do this. So let me add the function. We will need it at some point. Now this won't work. We'll need a name. Oh, I guess we could just use node. Yeah, there we go. That's good. All right, so then we could go npc.scene.find player. And then movement vector 0 equals 10. I think the player he also has friction, right? Yeah, friction does come into play. So we'll say for yeah, we'll just do it like this. This is gonna be interesting. We'll see if it works. But let's say for 60 frames, we want this to happen. So basically he's going to move, and I guess it would be actually that way. So basically he'll say something, and then for like 1 second he'll walk down toward the camera, and then it'll wait a second, and then it'll say this line. So this is interesting. We'll see if it works. Okay. It crashed. Okay, it crashed. That's fine though. So it couldn't find the player. Why couldn't it find the player? So we're looping through if the node's name is equal to the name. Oh, there's no player. Yeah, there's no player node. The player's name is called something else. It is Suited Man. Is that the name? I didn't name him player. I just named him because I wasn't sure if he would be the player character, so I didn't actually name him player. He's Suited Man. It's like, yeah, let's try this. All right, it didn't work, but I wonder why. Let's see. Yield. Okay, that's, yeah, we definitely want to yield. It might, let's see, is this running? I'm not sure. I have to see. I haven't done this kind of thing before. Where we're looping through a, okay, so it is doing this, but but it might be that the movement vector is not being set. It actually might be working. It might just be that the movement vector is not being altered. Let's see. Okay, so it was being set, but he's not moving. Is that because... I wonder why, actually. It seems like it is, like, being set. Oh! Oh, it's here. Well, what did I... Ah, okay. We went this. I completely didn't even realize. That was just poorly written code. Okay. Yeah, I didn't even realize that, like, friction was actually, like, immediate. Okay, that actually might fix it. Yo, let's go! It's that simple, dude. That's crazy. That's crazy. That's just like, that's so simple. That's so simple. Now this isn't perfect. We would like this to be maybe like you could do something over a period of time. So we can do that. We can make something. We can make a function that basically says I'll take a function and then basically do it and then yield like we're doing here. So let's do that. We'll make this. So we have wait until, and we'll just basically just copy this and we'll say do while. We'll take a function. And we'll also take a time period. Yeah. So I guess actually we could just, it's the same concept as this, just kind of in reverse. So we'll just copy this. Do while, so it'll be do. Oh, do I have to? Okay, there we go. Okay, so we say wait start time dot now, or, and we say if time since is greater than, okay, else we run do. That's it. So now instead of this, we can say event dot do while, and then we pass the function, and then we can say time dot second, and then we just do this. You can also just move that out. There we go. So that's effectively the same thing. It does the same thing, it just looks a little cleaner. It's simple, dude. It's so simple. That's crazy. Like that's the upside. That's the like the good part of Go, is that kind of stuff where it's just like it's easy. It's easy. How small am I in the preview? I'm not sure. I feel like I'm tiny in the preview, like in the corner, but that's fine. But yes, so that's feeling really good. The bird has been charged. Sorry for not reading chat. He says, I really need to get into Go. I tried it, but it was turned off. I was turned off by Go format, which wasn't optional at the time. I don't know if it is optional. Still, I guess it must be. Never mind. It is optional, right? I just like I use VS Code and the Go package, the Go add-on, and that just automatically has Go format on. But I don't think you have to use Go format, and I think there's other options for formatting. I know you can use Go format, but there might be another one or two. I feel like there's other options. Well, let's see. I just want to check. Yeah, okay, so yeah, you have Go format, you have Go FMT, Go format, you have other options. Yeah, okay, so it's not just that one. So you might be able to also choose like, wait, was there an option to disable it? No, so you can't, wait. So yeah, it doesn't seem like you can disable it here. But I guess you could just essentially disable it by not. Well, maybe you could use, I guess, go FUMPT, or I'm sorry, go format, because you can configure it. So you might be able to use go format and then like pass an option to turn it off. But yeah, this is I'm happy with this. This is what I found to be great. And let's compare it. I don't know if I can easily do so, but let's try it. I will try to open my Godot. My Godot Iquia. Event system. So this is, in comparison, this is sure. Let's install the Godot thing. But yeah, now we got a visual, we got highlighting. But in comparison, this is a much more inflexible system, because there's some good, okay, so here you can kind of see where the downside is, because basically we're making functions that return objects that exist in an array, in an array, and then we basically are looping through all of these objects to determine the flow. So for example, this sets a name tag, so this is a function that returns an object that sets the name tag of the character talking, message, displays text. If then evaluates some if statement, and then if it's true, it gives you, or it executes the next following object. So this is not great. It's passable, it's fine, you can use it. It's not fine, but I mean, you can use it. It's usable. It's not really good, but it's usable. But in comparison, it's kind of clunky. And this is, as far as I found, the best, or it was kind of like the way to do it. Like, I couldn't really come up with a better way. Basically, there might have been a better way, maybe more so using Godot directly rather than defining my events in text format. But I didn't really like this system. It wasn't bad, but it was okay. Yeah, it was okay. In comparison, this is clean. This is cleaner. It's much cleaner. Yeah, so this is cool. I'm happy with this. Carl Otto says hello. Thank you very much for stopping by. Yeah, okay. So this works. It works well. It works fine. So we will do this. Wait until message. Something like that. Okay, so this is working well. We're gonna go ahead and add another event for the clock here. And so I was doing some thinking about this game, and I thought it would be cool, it'd be interesting if essentially you play a Yakuza or like a gangster who's coming to extort money from this guy who's like a shut-in. He's essentially, the shut-in, he's essentially like, kind of like living in his own detritus. Like he's, there's trash everywhere, his house is in disarray, and you as the gangster are coming to collect money. And in doing so, you have to solve puzzles and get to the guy in the back of the house. And in the process, of course, the gangster's like kind of learning about himself, and it's like an introspective process as he's going through this adventure. I think that would be interesting because people playing as a bad guy who kind of doesn't want to be a bad guy and is kind of actively fighting that process through the course of the adventure sounds interesting. John Pond says, "Hello, folks. Hello. Welcome to the stream." So yeah, here's the clock. So we're gonna just give it an NPC property. The integer. Yeah, one is fine. Save, export. And then we'll just do this. Let's see. This portrait at the all right, let's see if that works. That was so simple, dude. That was so simple. Oh my gosh. That was actually so like dead simple, dude. Oh my gosh, that was actually like extremely simple. I wasn't even expecting how simple that was. All right, well that was sick. Yeah, that was easy. All right, so let's design the world a little bit more. The area, the game world. So I think I want like a staircase that ascends into the landing. Now I'm not sure how I'm gonna, not quite sure how to do that or how I'm going to do that because I gotta think. Hold on. Well, let's do it first. Let's grab some of these tiles. Should have. Yeah, let's just design it from the bottom here. Ah, okay. Let's kick it out a little bit like that. Okay. And we can just... Thank you. And also, can we clean up the person's fields? Yeah. Okay, so yeah, we're gonna make basically an entranceway, I believe. Because this is too wide. Yeah, I guess it doesn't really matter. We'll make an entranceway and then we'll kind of go from there. So this will be here. That's true. This is 3D, so we don't actually have to worry about like tiles. Because there are no real tiles. This is a fully 3D game, so you can just be like, oh, this is a half tile. Which is what I'm going to do here. Oh wait, we need corners here, so this one. Okay. All right, so now we can kind of flare this out a little bit. Go here, go down here. These can both be corner pieces. All right, so now, yeah, we're gonna, oh, I need walls. Completely forgot about walls. All right, so yeah, what we're gonna do at some point, we need to essentially, we're gonna essentially need to what will we need? We're gonna need stairs, or at least I'd like stairs. So that involves basically something invisible that the player can walk on. So we'll see how this works. I guess first thing we're gonna do, we're gonna kick this out a little bit to give us some room, and then we're gonna kick it down. Something like that. I feel like that wouldn't be too steep of a staircase. Probably wouldn't be actually that big. We'll just keep it like something relatively small. We'll keep it, yeah, something like that. That's even pieces. Okay, so we're gonna do this a little bit oddly. Something like that. Which means this piece actually doesn't need to be there. Actually, we'll leave it there, that's fine. That makes it a whole tile. Whole piece. Alright, we'll go something like that. We'll move this down. Okay. That works. Okay. Now we're just gonna clone this over here. And that's about it. The wall would have to be further. Whoops. The wall can, we actually can just actually be working layout to see more. Gonna be interesting. Okay, so the plan here is exactly this, but we're gonna sink this down to basically match the staircase. Yeah. That's basically perfect. It's a little jank, but that's fine, I think. All right, now here's the thing that's going to be interesting. Now, because I do want stairs, and we are gonna need, I think, some kind of a little bit complicated geometries here and there. I'm not sure how. Well, actually, we'll see if we can. We'll see if we can climb the stairs. Let's see if we can climb the stairs. I'm not sure if we will, but let's see. Carl says the way you make objects so fast is, or the way you can make objects so fast is really great. Thank you. Yeah, it's both the tools and everything are kind of coming together. That looks pretty good. Looks, stair-like. It's the character is floating above the ground. You can see it in this debug. Well, he's not sinking. So we need to actually make it so that he will sink. So let's do that. I'm not sure if this will work, but let's see. Okay. We can do it this way. We're just gonna apply a little bit of a downward force. Oh, actually, that's an upward force. Whoops, he's gonna fly up in there. We're gonna apply a little bit of a downward force that will kind of keep him on the ground. We'll see if that works. I'm not sure if it will. Music Boy J Boy says hello, hello. Oh. Okay. Oh, it's because I see. I know why this is happening. I think. Yeah, we need to clone this. There we go. Okay, so yeah, he's a little bit lower. You can see that the shadow is no longer above the ground. Let's see if he doesn't seem to be. He does move slightly differently. He's bumping into stuff. That's not good, but that's a good sign that at least he's moving down. Let's see. All right, so he went down the stairs. And he went up the stairs. Okay, so that does work. He slowly like slides down the stairs, which is kind of funny. All right, that's not so bad though. I mean, like this is like not good, but everything else about it is pretty solid. He does feel fine moving up and down stairs. He does like kind of hang a little bit, like he's not hanging, but he's like. It feels like he's moving a little bit slower going upstairs, but that's fine. I think that's fine. If we made the steps fewer, that would actually work pretty well. Now that I think about it. Music Boy says, "Can I ask you a question?" Yeah, feel free. So yeah, we'll have to figure out what to do about him like bumping into the wall like that. In the corners, it's fine, but on the sides, we have to figure out what to do. So I think that issue might be caused by this. We probably can just do that. Music Boy says, I know this isn't a music live stream, but how do you... Whoops. We can't do that. That's right, because he's... Yeah, that's right. That's how he stays on the ground. This is an interesting issue. How do we make it so that he stays on the ground, but when he goes into a wall, he doesn't bounce off like that? This actually may not be an issue with our code here, but might be an issue with Tetra. So let's take a look at that. Music Boy says, I know this isn't a music live stream, but how do you make your chords and chord progression sound so good? Well, I tend to use chords I like, so I'm not very good at, I'm just kind of now moving into chords, like passing chords or using chords that I don't usually use. But basically, I usually go for the main chord in a key, or not the main chord, the first chord, like the root chord. I usually go for that as either the end or the beginning of a progression. I usually use just like 3 or 4 chords in a progression. Let me turn up the song I'm listening to here. Hold on. Okay, so yeah, listening to this specific song, it kind of, you can hear a lot of like what I usually like to do in my songs. So like in this part, I like to just kind of vamp. I think that's the right term. I think that's a music term that kind of describes what I'm doing, where basically I just kind of like rock on a specific, like maybe 2 or 3 chords, and then I transition into the bridge or the chorus. And that usually is like my bread and butter chords. So in this example, on these chords, Like you can hear the basses doing stuff, and I turned it down, but you can hear the basses doing stuff. But it's basically kind of staying in kind of like one location. You know, like it's moving, it's doing different things, but the chords are kind of like just kind of staying in the same place. And then once you get to this little bit here, it changes. Or right there. And then from here, it goes into the chorus. So it's basically like I generally go with that. I go with that process, and it's kind of inspired by like SNES games. Primarily like kind of gives like a kind of busy, you know, kind of like not dystopian, but kind of like a, you know, jazzy feel. That's kind of like my main bread and butter when it comes to video game music. I basically go for that, where you vamp on a specific, you know, like one or two chords with like percussion heavy, rhythm heavy, and then from there you go into the chorus, which is also percussion heavy, but kind of more is busier, and also the chords move around a little bit more. And it usually starts with or ends with the first root chord in a key, more or less. I can kind of go into it deeper on a music stream because I'd like to actually like kind of show my thought process. And I'd also like to do it with a camera pointed at my piano so you can actually see the chords I'm playing. But overall, it's pretty simple. I think it helps a lot if you like listening to if you listen to different genres of music, and then you can kind of combine them with your style and work on them. But also, if you listen to music from video games, you can kind of like, if you want to make music that sounds like something from, let's say, Secret of Mana 2, also known as Trials of Mana now, but Trials of Mana for the SNES, which was on the Secret of Mana collection on the Switch. If you listen to a lot of those songs, they're fantastic songs, great songs. If you listen to them, you're like, man, I really like those songs. Try to make songs like that. Like, you know, you can be like, okay, I hear the chord progression, I hear the general feel, you know, let me try to like imitate that. And once you do that for a little bit, you know, once you get 10 songs in to trying to make, you know, Secret of Mana songs, your songs will start to sound like Secret of Mana. Like it happens pretty quick. Like once you like make a concerted effort to like understand like, oh, these are the chords and this gives that kind of dreamy feel and that feels very melancholic and sad, then you'll start to like understand like, oh, it's this kind of specific rhythm or this kind of a specific you know, falling of the chords that gives this feel, or maybe I should hit these notes that are outside of the key just to give a little bit more dissonance, which feels a little bit more painful. You know, you can kind of feel your way through it as you're making songs. Yeah, it's interesting. Thank you for the music tips. I've been trying to make music with very good sounding chords and melodies like you and Fear of Dark. I am nowhere near Fear of Dark. Fear of Dark is on another level. He might be like the best chip musician in on earth. Like his chords are like ridiculous, dude. Like his feelings are the feelings from his chords and his songs are just like, it's just it's weird. It's good, but it's just like, it's very unique. And I love his music. He's great. Yeah, I wouldn't put me and him in the same level. I'm way down there. But yeah, I feel like I kind of been stagnant in that I kind of do the same thing over and over again. So I'm trying to like branch out a little bit in terms of the chords I use and the rhythms. But overall, I would say the thing that helps out a lot is kind of listening to songs you like from, you know, media you like, from games, from music, and then making something that kind of like works the same. This works pretty well. That's not good. Now I think let's take a look here, because I'm pretty sure what's happening is The MTV, which is the minimum translation vector, I should probably put. Yeah, why does this not give me this documentation here? Okay, maybe it was just VS Code just doesn't give it. You hover over it. I guess it just doesn't. Okay, that's weird. Yeah, I think the minimum translation vector for capsule or sphere triangle collision is just it might not be combining values very much. So like that actually might be what it is. Let's take a look here. That we can kind of confirm that by doing this. I think what's happening is when we collide with the ground, we're pushing up by basically gravity, but when we collide with the wall, we are not pushing up by gravity, and that's really what we're seeing here. Yeah, so you push up by gravity, we'll move back history. Push up by gravity, you walk into the wall and it pushes you back. And it pushes you back and it pushes you back, and then you push up by gravity. So it's just like it's not combining them. So I need to figure out how to combine them. I have to figure out how I want to do that. Music Boy says, I like your music too, your chords and melodies. Trying to make a new song on the moment. Thank you. Yeah, it's interesting and it's fun to make music. Even if you don't feel like you're getting better, you are getting better. Me included. I think we all get better as we do more, as we work on stuff, and it's interesting to hear like, oh man, this song like is my favorite song of mine. And then you come back, a year later and you're like, it's pretty good, but like this new song is my favorite song of mine. And so it's fun to make stuff. So yeah, we need to basically figure out how we want to do this. Now, yeah, the way that Tetra does sphere, triangle, and capsule triangle collision works, I think, fine. I think the issue is that if you are colliding on multiple angles, it basically is just giving you the one that you collided with the most, which may not be enough. Let's visualize this using a handy numbered list. No, let's visualize this thusly in Blender. So we'll add a couple of planes. Like so. Let me get a sunlight. That won't blow out our eyes. Thank you. Okay. So the general idea here is this is the player, right? We'll make him something like this. So he's moving and he's, moving into the ground, so it kicks him back up. That's the MTV, the minimum translation vector. But when he moves in like this, how should it kick him out? It can't just be like, oh, well, you're further into the wall, so let's just kick you out like that, because he's still in the ground. The correct answer is basically to add both of these vectors together, right? So it moves him up and it moves him out like that. Now, why am I not doing that? I feel like there's a reason why I'm not doing that, but I'm not sure why. Let's assume that that's a good idea, I guess. Oh, the reason why I'm not doing that is because if you have a situation like this, right? Like we'll just join these together. Yeah, I did. Okay. If you have a situation like this, or just to make it simple, like this, you really want to push out of both triangles like this, right? You don't want to push out by this amount times 2. You don't want to push out by both of these triangles because they're the same. You want to basically combine them as necessary. So if you have two, so do we combine them by dot? Or maybe I don't. This is why I'm not combining them. I'm not combining vectors. Because if you combine them flat, then you would just end up in a situation like this where you would move out to like here, which is bad. You don't want to move out that far. You want to move out to here. So how do we combine vectors in a meaningful way? So you have two triangles that you're in, let's say, one unit. You want to move, but they face the same distance, same direction, and they're the same distance away from the center. You want to move one unit away. You don't want to move 2 units, 1 for each triangle. So this works. We're moving out from the triangle the distance, that is the radius of the sphere, which is the same for the capsule. Oh, let me get the music back up. Actually, let me get some thinking music. I'm not sure if that'll actually help me think, but let's... This isn't thinking music, but let's get some funky music nonetheless. All right, so we want to kick out enough distance to be away from every triangle. This is a sphere, let's say. Let me look at sphere triangle. What's this one? Carl Otto says, I'm glad it's not just me that needs different music for different types of programming. That's a good point. maybe I do need different types of music for different types of programming. Maybe that's what I've been missing. So we're moving out from this distance. We can't simply move out from this distance as well. We could go with whatever one is bigger, but that's what we're doing currently. Really, you want to move out. You can't just add. Well, let's try a different example. Let's say we had a situation like this. How should this object, and actually let's just, okay, so how should this sphere move? It should move out from here until here. But then it should move out from here until here, essentially. Or I guess actually there. Or like that, either one. Actually, just let's kind of simplify this. So in this position, where should or something like this, where should the sphere move? It should move up out of this ground, and it should move out from these triangles, basically there. So do we just keep doing it until we resolve all triangles? But we don't want to call this multiple times. Like, we don't want to have to call like BT sphere triangles multiple times. Instead, we should just like add the vectors together. That's the general idea. So if we were to add the vectors together, it's like, oh, this needs to move up, this needs to move out, this needs to move whatever direction. Then we just go by the distance, the maximum distance in. This is 1.2. That might give us more so what we're looking for. Let's give that a shot. Let's give it a shot. Here's what we're gonna do. It's gonna be a little interesting. We don't want to actually multiply the MTV until the last step. So we'll do that here. We want to add all right, something like this. So MTV is, we're adding distance. Yeah, something like MTV was add delta unit. Closest disk. Wait, closest disk? Shouldn't it be the furthest? Also, do I use contact? I do, okay. Contact is equal to nil, or D is less than this. Okay. We're gonna try something like this. All right, this might get us kind of there. We will see this not here in player because we have to act this. I edited the collision or the intersection code for sphere triangles because the capsule is basically a sphere. But let's just do the sphere first, and then if it works, we can just adapt it for triangle for capsule. But we will go to Tetra3D. We will go to examples. That's it there because we have a sphere there, I think. Yeah, see, this is what we don't want. All right, I think this is fine. Sphere, oh. That might be better. The answer is no. Yeah, it doesn't like being between two objects. Okay, let's see. .9 1.8 0.8 no 1.8 Oh, this was supposed to be this. So we just want the largest distance, right? Is that not the closest distance? I guess it must be, right? So yeah, let's try this. We'll have closest dist. Yeah, we'll try that. We'll see if this works. All right. it's wiggling, like just barely. It's barely like wobbling back and forth. It's like bumping a little bit. Popping off with that game engine dev. I don't know about that. Yeah, it's most bad when you're colliding against multiple triangles at the same time. How can we resolve collision against multiple triangles at the same time? That's the question. Okay, here's what I'm gonna do, because I don't know if I have the necessary information, both in terms of my personal knowledge as well as my execution of that knowledge to get this to work. Because essentially, if you're on two triangles, how do you resolve it? Like you can see it's bouncing because basically the vector, I can't use my mouse. The vector basically for the triangle on the right is less than the vector than the triangle on the left. Like they contribute different amounts. So I guess we could. Nah, we're already getting the unit vector of those. They should be equal length, but basically they're not equal like proportions. Like one is like this, and the other one's like that, and so it's kicking it over to the right, and it will happen over here, I think, as well. Or at least I believe it should. Anyway, it's not working the way it should. So a tiny bit of momentum. You might do X and Y and do Z separately so it doesn't bounce up. That's the second concept I was thinking of. Yeah, I might just basically do Z separately and then check for X and Y collision, because I don't know that this isn't the right way to do it. It definitely seems like it works. Not this, but I don't know that specifically this isn't the right way to do it. It definitely seems to work, and that's it's the code that I believe, I adapted properly for this purpose, and it does seem pretty much rock solid. Like it does work really well. Wait, why? Wait, why is it? Now I'm wondering how is this sphere working like smooth, and the other sphere isn't. This is fine, but the actual game demo isn't working. Like this works fine. Is it because I applied the gravity? I applied the gravity before. That might be why. Maybe that's why. Maybe it's just an order, literally just about when I apply the gravity. But let's try doing that. Let's try applying the gravity before. Okay, let's try that. When did I ever do it? Oh, I moved this stuff, or the collision up here. Oh yeah. Why did I do that? That's so stupid. That's why I did that. Oh. Okay, that explains things. Okay. So here's what we're gonna do. I think I actually just like messed myself up. I should have been applying checking for collision out here, I believe. And then we can just do this way. Wait. No, yeah, this is fine. You know what? Let's do this. Let me think about this a little bit. Yeah, this is gotta be a better way to do this, right? Well. I mean, there's, yeah, because basically we're looping through the bounding objects list, which is basically a list of a slice of objects that are collision enabled, essentially. And then we're basically saying, oh, is the NPC checker, which is just a sphere, is that colliding with it? And is it an NPC? If so, then we can interact with it. But then we also do it again to basically see if the player is like moving into it. It'd be nice if we could kind of like consolidate this, but at the same time, I don't know, it's not like a huge problem. All right, well, that was it. I was just doing it in the wrong order. It wasn't actually an issue, I think. No, wait, we're not syncing anymore. I didn't add gravity back. We need gravity probably here. Something like that. Yeah, still doing that. We probably should do this a little bit of a different way, because we need to move it in order to check to see if it's intersecting, at which point we can move it back. So why don't we do it this way? We could make a function yeah, let's just do it. Let's do this a little bit of a simpler. Oh no, that doesn't make sense. It's not good. So we move, then we see if we're gliding. Why was this working before? That's the thing, or what? Not before. Why does this work in the demo, in the collision demo? How am I doing it there? So I'm moving the object directly, gravity, before. No, I'm moving it entirely before. Then I check for collision. Okay, well, isn't that how I'm doing it here? Yeah, isn't... Interesting. Okay, so that's him sliding down the, yeah, going into the abyss. So if that works, then this should work. Yeah, okay. But then this is janky. Why is it janky? It's definitely not otherwise. Let's see. This also minus. Let's do this. Let's do a couple things here. Firstly, go with that. Yeah, so this is interesting. Hold on. Now we should be able to at least have like a y vector, a proper y vector here. Or just more gravity. He's... okay, let's see, hold on. When we get friction involved... magnitude is greater than 0. Friction vector is... I don't know why. That invert unit scale. Friction add friction vector, okay. Yeah. Vector magnitude is greater than max speed. No movement, no y. Y scale there. I guess I should excuse me, maybe I should have had like a movement vector and a speed, because basically movement vector is the speed he's moving, you know, around, but then he has gravity, which, I mean, really he doesn't need gravity. I don't even know why I'm doing this. He doesn't need like real gravity, like true gravity. He just needs to move down. That's it. So yeah, why don't we just say like, oh yeah, let's just like literally move him down. To just like simulate gravity. Because I mean, he's not going to be like jumping. He's just going to be walking up and down objects. All right, so he's falling. That's fine. He can't climb stairs because he's falling too fast. Interesting. That, I mean, that at least proves kind of what we need to do. So this should definitely work. It's just a matter of fixing this bumpiness. Why is that happening? I feel like it might be just a matter of like yo. Hold up. I might have kind of gotten there. Yeah, I might have figured it out. Let's see. No, okay. Maybe. No, that does call dirty transform. Okay. I was thinking that might be just like it's not updating things properly, but that's not it. There's definitely something going on that's making him like jump around, and I'm not sure why. But once I fix it, oh, you better believe we're gonna be cooking with gas. So we're moving down. We're moving according to the movement vector. Just a little bit down. And then we check to see if there's a collision, and if so, we move back on the movement vector. Also, how long? Let me just... I want to see how long does this take to do. Like, ideally, it should take, you know, 1/10 of a millisecond or something. It takes 1 millisecond? Rat. Capsule intersection. Actually, let me see. How long does it take? How long does it take according to each individual object? You're supposed to be able to tell me the node. Picoseconds, milliseconds. I guess it's just 3 actually. It's probably just in groups of... Yeah. be over and over again. So one of them is obviously the terrain. There's kind of a lot of polygons here for a visually simple scene. It's like you get the drop down for statistics. It is 1,200 triangles. Okay, so that's kind of a lot, I guess. Could still probably optimize this more, but for now, that's fine. So let's just try to figure out what's going on with this bumpiness. Carl says, maybe leave a tiny gap so he isn't intersecting the floor. It would make this shadow Z-flash in it anyway. It would fix it. Yeah, I'm definitely gonna fix the shadow and just move him up. But he needs to still be able to... Like, we can't have him just be bumpy. You can't call this multiple times. That's way too wasteful. And we could probably also improve performance by segmenting this terrain out into multiple pieces. We don't have to have this be one big map. We could have it be segmented into different sections, and that would improve collision, like the collision detection time. Let's see. But this is happening because let's try this just to kind of see if this is part of the problem. Yes. Okay, so that is the answer. That is the problem. Okay. So then we need to handle ground collisions separately, essentially. Okay, let's try this. This is hacky, extremely hacky, but let's see if it actually solves the issue. It does. Yo, this is so stupid. Well, fundamentally, what we probably need to do is what we need to do in a normal 2D game, which is decompose movement into two different axes. Like in a side scroller, you would decompose it into horizontal and vertical movement. In 3D, we would decompose it into the horizontal plane and vertical movement, which means basically we would do what we did before just a second ago, where we check for collision after moving vertically, and then we check for collision horizontally. Yeah, that's the right way to do this, but I can't spend 2 milliseconds twice, or 1 millisecond twice, either one, twice for collision detection. That's ridiculous for the player or any object. This is, a relatively simple scene. But it needs to be faster. Definitely needs to be faster. Let's see if we can make any kind of sweeping improvements. All right, sphere triangles. Okay, the problem is definitely going to be probably like in this area. We're looping through every triangle. We don't need to compare or let's point on try. You know what? Let's profile this. I mean, I guess we could profile it like directly using CPU prof. But where's the fun in that? RP Prof. Let's see. Start CPU profile. Oh wait, can I just use like T is... Like I'd like to just get a string or something. New writer. Oh, writer. Nah, I just want to. Would it be a byte writer? Bytes dot. No. Hold on. Let me see if there's a way to. Bytes buffer to capture the output. All right, let's try that. I want to see if I can like. Oh, oops. There we go. I just want to see if I can do it this way, right? Where I basically stop. See, well, and then I'm pretty sure this won't work, but I just want to see what happens for one. But then also I want to see if it's possible to write directly to a basically a string and then print out the results. You can't do that. Never mind. I just realized I need to. I was like, wait a second. What am I doing? This completely wouldn't work. I need like this. It needs to write to a file. All right. So yeah, that's my bad. os.open. All right, let's try that. So let's see if it gives us anything out for the CPU pprof or something. It does not. So it might be that it's. Let's try like. Maybe push him back, but then also remove his velocity in that direction. That actually makes sense. Does this not work? Let's see. Maybe. Is this? Oh, sphere triangles. Wait, how is this even calling sphere triangles? Oh, the player is this? Oh no. Okay. Is the whatchamacallits. Okay. My bad. Open file or create. That's what I was confusing open with create. All right. There we go. Okay. No samples. No samples, no samples. Is it just taking not enough time? 201 milliseconds. One millisecond. Yeah, sample. Oh. Yeah, I don't think there's anything here. Let's open the tape folder. I don't think there's anything here in either of these. Yeah. Nope. Nope. Okay. So it's not taking enough time. I don't think it's taking enough time to really like do much. So here's what we're gonna do. We're gonna go back to the bounds map. We will not save. And then we're just gonna like absolutely wreck this thing here. 33,000. Export this. And then see if this gives us something. Okay. Yeah, it's definitely collision time. So, it's this really. It's creating the CPU and then also collision time. But this should give us. It did not give us anything. It didn't give us a CPU prof. That's weird. That's out of the ordinary. Oh, there we go. Okay, so now let's try this. All right, we got a little bit of a sample. It's just 201 milliseconds. Actually, hold on. So this is 9 FPS, 4 FPS. Let's cut out this part. I want to see if capsule is just slow compared to sphere. As far as I know, it shouldn't be because it's relatively. Actually, it would be a lot slower than sphere now that I think about it. Let's see. 10, 11 FPS, 9. Okay, so it's not that much slower. 9 to 10. It's pretty similar. All right, let's take a look at which is good because we want to know where it could be faster. And if it's just in capsule, then that's one thing. But if it's in capsule or sphere or whatever, if it's everywhere, that's good because that's something we can optimize. We are going to go to Tetra. We're going to samples. All right. So it's the dot product, or it might be the dot product. Let's cut this out. Or at least let's, like, this is by no means, I think, the right way to profile. I think that this is not going to work very well, but it's fine for now. And this is in sphere, yeah? Okay, so closest point on try, closest point on line. Okay. This is dot products. Can we avoid doing dot products? Point online. I think the answer is no. I think this is the fastest we could possibly do it, but we might be able to optimize it more. We could definitely avoid allocating vectors here. Might be faster not to use min and max. And we could definitely avoid allocating a vector here. Okay, so we're gonna do this way. We'll try this. We're subbing out in by start. Okay. In start. We can do this again. Point and start. And then start. Okay. Easier if we didn't have to render the triangles if it were invisible. All right, let's do that. Let's make it more reliable. We'll go bounds. Let's go to what is this? Ground. Okay. 14, 18, 17. On the sphere. Okay, let's make sure that this is where we at. Mountains. Let's just say return nil. I want to see if it actually is taking time because of the collision check. Alright, so it is indeed. When we're controlling this capsule, it's super slow. When we're controlling the sphere, it's not. Alright. That didn't help that much. I think it is just a matter of we're looping through all the triangles, so it's just going to be slow unless we can appreciably improve speed. Fast vector sub. It's fine. Square. Is this? Contact is equal to nil. Okay. We're making very little contact. Okay. Well, we already know that it's gonna be slowest because of closest point online. That's definitely gonna be the slowest part of this. This is, I mean, this I guess could be slow actually. Determining cross products of lanes. All right, let's do this. Let's do this the right way. I don't know why I'm like trying not to do it the right way. We're gonna optimize. Let's optimize. we will just press edbtn.pp. Okay. I'm not sure if this actually will work, but we'll see. Let's delete this. Okay. All right, so it did work. So we'll just keep the camera anywhere, really. Okay. CPU or Go tool. All right, so we got some data. This is the old data. This is the new data. Better. Okay. So dot products are taking up 0.43 seconds of 1.74, so a significant portion. Sub is a little bit. Okay, so it's malloc. Got it. Okay. And apparently that's in closest. Closest point on try. Yeah, we're using dot products all over the place. Point dot sub. Okay. We're gonna try to make this a little better. One, two, excuse me, 3, 4, 5, 6. I think we can get by with 6. Okay, so we're gonna say plain dot vector pool dot sub is v1 and v2. Okay. v2 0. Do we have a cross? Okay. Let's see. First and second. We will assume that it will work. Okay, so And X, Y, and Z are just 0, 1, and 2. Okay. 1, 2, 0, 0, 2, 1, 1, 2, 0, 2. Did I do that right? I immediately doubted myself. We will do this the easy, lazy, scared way. Because I cannot trust myself. All right, so this should basically be it. Any vector pool. All right, we don't need this. We can do that. Dot, normal dot. We don't want to have to allocate another thing. So let's figure out what a dot product is. It's gonna be this. Zero is V0 times V1 0 0. Let's just 1 1 right here. Oh wait, does well, I guess this isn't that slow actually. Yeah, well, yeah, this isn't very slow. We won't have that. Okay. We're getting there. Normal dot. Well, I mean, this is kind of slow. How fast is length? I guess that must be, that could be kind of slow. Well, it probably shouldn't be that slow. Slow, multiplicate. Okay. All right, so this should be kind of better. Append is slow. Wait, is right? Point dot sub, yeah. Append it could be slow, but or if it is slow, this shouldn't be happening. Append shouldn't be happening because this is only appending if basically the two variables you're passing into dot here are different dimensions, which they're not. You know what? No, they're always 3 dimensions, 3-dimensional. Yeah, so that shouldn't be too slow, I think. All right, so we should kind of be where we should kind of be there. So this gets called says 1 point inside triangle. Oh yeah, this is probably more so where we're getting slow. Dang. Point inside. Are we just using here? Okay. Point inside triangle. All right, here's what we're gonna do. B1. Point 0. All right, so this should kind of help us out. So there's 3 plus closest point 4. That 5, 6, 7. Yeah, so somewhere around 7 vectors should be necessary here. So that might have kind of helped us out a little bit. All right, so that might have helped us out. Let's see if we get, before it was like 12 or 14 FPS. It crashed. It's a good sign. Let's see. Index of length 3. Is it 4-dimensional? Yo, you might be right, Carl Otto. Maybe it is 4-dimensional. It is. It is, dude. I had no idea. Okay. Why is it 4-dimensional? This is before it's transformed. Yeah, that's weird. Why is it 4-dimensional? All right, here's what we're gonna do. We're just gonna. Oh, because it's transformed by the it's multiplied by the transform. Okay, that kind of makes sense a little bit. Although it doesn't make sense because sphere multivec does not return a 4-dimensional vector. Why is it 4-dimensional? Let's see. It's controlling the capsule. That's clear. Right, okay, capsule. Closest point on try, okay. Why is it 4-dimensional? Top, capsule, bottom, top. Yeah, okay, there is no this isn't 4-dimensional, this is 3-dimensional. Okay, so then where is it getting the 4th dimension from? Try that center? Maybe... No? Yes, no, no. Maybe? I wonder if it is appending. I don't think it should be. Yeah, closest capsule point is not 4-dimensional, so why is it 4-dimensional here? Point inside triangle. I mean, it doesn't really matter, but still, it kind of does. Plane point. Oh. The normal is 3-dimensional scale. Is the normal not 3-dimensional? Like, it doesn't really matter. I could fix this another way, but I'm just like, it shouldn't be 4-dimensional. Is it, are all vectors all vectors are 4-dimensional? Whoops, that's an accident. All right, we will do this, I suppose. That's kind of a hack, but we'll see if that works. All right, yeah, it's not gonna work, or at least that doesn't solve the issue. Okay. So here's what we'll do. This is part of the problem. Let's see, here goes into point inside triangle, point triangle, plane point. Okay, so now we're kind of getting there. Kind of. All right, so let's say it doesn't really matter. Let's say we just have 10. Really? Oh, I see. We have to call. Oh no, wait, we can't do that. We have to call cold. Hold on, set. There we go. That might do it. Does it load? Yes. Okay. All right. So we're getting 13 FPS with the capsule. You press F. You're working with the sphere. You're getting 18, 20, 19. So that's a little bit of an improvement. A little bit. That's actually not bad. It's like a 20% improvement, something like that. 40. Went from like roughly 14 to 20, yeah, 20-ish, 23, 20, yeah. Not bad. That's almost 100% improvement. That's pretty good. But yeah, it might be that append is what's happening. Where was append? Was it with cross? Was it with which function was it? It wasn't dot. Was it cross? It's cross. Are we using cross anywhere? No. Okay. I thought we were. There's a collision plane here. There's only one plane. Oh, so there's only one. Okay, so that's fine. Are we using closest point on the line anywhere? We're using it all in the plane. All right, well then let's just. All right, so now there's 3 extra calls. That means this could be. All right, so that's the general idea here. So we managed to get squeeze out a nice amount of FPS, a little bit of an FPS boost. Not an insane amount, but a pretty good amount. And yeah, that's a pretty good start. I mean, those passing pointers instead of copying would be a decent jump in speed as well, I think. All right, am I not? I'm passing pointers. Aren't I? Because these are vectors, but they are float arrays, float slices rather, which are pointers, right? And then I don't think I have to do anything to benefit from it for capsules. Did I do anything here? I did. Yeah, no. A capsule could be maybe faster. How can we make this faster? Yeah, this is definitely just going to be slow. Well, this could be faster. Yeah, actually, probably just like... that, this, capsule line is what's that? Max f min bottom dot f line dot t. Eat that. The delta not need to clone this? All right, that's an improvement. I think this was like 10 FPS before, now it's like 15, 17. Almost 100% improvement. That's not bad. And then the sphere is up to 22. Yeah, that's a lot. That's a significant improvement for 37,000 triangles. The fastest, the best improvement we're probably ever going to make here is probably going to be something along the lines of not checking triangles if they straight up just aren't near the sphere, which we probably can do. If the distance to the center point of the triangle is greater than the distance from the extent. Like, let me bring out a sprite for this. That might be an optimization we can make. It's just a very rough brat. If this pops up with little... All right, I guess we're cool. Yeah. So here's the idea I have here. That actually might make a. This is probably why I should have done it to begin with. But if you have a sphere here, right? That's a horrible sphere. You have a triangle here. I don't know how I messed up drawing a triangle. There you go. So the idea is basically if the distance from the sphere to the triangle is greater than the distance around the triangle from really any, like the greatest distance from any vertex to the other vertex, then it couldn't possibly be touching. So we don't even have to like get the closest point on triangle or anything like that. We can just be like, hey, how big is the triangle? And then go from there. That's the idea. It would be the distance from the. We can try it. I don't know. I feel like this might it might not work, but we can give it a shot and see if it does. And this is for capsule. Let's go back to a sphere. But yeah, we say basically because we already have the center of the triangle. So we really need the extents. So we can calculate that beforehand. That makes sense. Yes. Yes. Okay. We'll just do something like this, largest distance. When we set the vertices, I guess actually when we call recalculate center, say try dot largest distance is equal to math dot max. I'm thinking. Minimum and maximum spatial dimension. Maximum. This is really what we want. So where do we actually set that? Let's see. All right, so I'm just gonna crib this real quick. Say. We'll see if this works. I feel like it might. And then we can say try to furthest. All right, so this is the general idea here, where we can basically tell how big the triangle is. That's the idea. So we'll say f and t, print line, try dot max span. What do I make? Okay, so it just starts with 0, 0. Got it. Okay, so we're pogging. We're pogging a little bit. This is okay. So let's see if this works. So this should give us basically the distance between the max. We'll see. All right, so 1.5. All right, so it is doing stuff. So here's what we're gonna do. We're gonna delete a lot of this stuff just to make sure that we're kind of like dealing with a known quantity. Okay. Oh, because it's not intercepting the bounding dots. Okay. All right, so if this works, it might work. Let's see. All right. It did not work. Let's see. Oh, I think because it doesn't have a collision object. Yeah. All right, let's see. All right. Okay, so it says it's 32. The dimensions are 32, so that is close enough, I guess you could say, where theoretically the object could be like basically there's a box around the triangle, kind of. So now if we go back over here to here, we can say if yeah, fast vector sub sphere pose try.center.add, or no, try.center dot magnitude is less than try.maxband, greater than try.maxband. Continue. So this might work. This basically might allow us to skip triangles that are just too far away, where it's just like there's no way you'd be able to theoretically be colliding with it. So if this works, then we can reload. We can have, you know, an insanely large and complicated mesh, which is 33,000 triangles. We can export this. Then we can go back to here, make sure the ground is invisible again, and let's see if it works. All right, so we're sitting at 14 FPS with the capsule. Switch to the sphere, we're sitting at 60. Oh my god. No way! No way! No way! Oh my gosh! No way! Are you serious? Dude! Oh my gosh. I know, there's no way. There's no way. I must have done, there must be like inaccuracies or something. There's no way this worked nearly as well as that. Novice Art said, what did I miss? You might have missed the greatest breakthrough in all of human history, my man. I don't know. Yeah, I missed something important. You might have missed something important. So, all right. So here's what we got. We have this super complicated mesh. It's very dense, as you can see. It's 33,000 triangles. I'm switching on the debug view so you can see. It's this. You know what? Let me just give this a little bit more like resolution, so it's not so harsh on the eyes. But basically what I was trying to do is optimize my collision checking code. Yo, it just crashed. Oh, it's probably because I'm running too many triangles. Okay. All right, we will split this into two different objects. We have two different halves. Okay. It will export this as. So basically, I was trying to optimize my collision checking code. And I think I might have gotten it. We'll see it in a couple seconds. All right. So you can see here, we're sitting at 30, 40, 50 FPS. If I press F2, you can see it's super dense, the collision mesh. Oh, capsule just slides right through the ground. That's no good. It's no good. Here it doesn't. All right, so yeah, I'll have to fix that in a couple seconds. But basically, I'm trying to optimize things. We have the super complicated collision mesh, which is currently, like, because I split it up into two different objects, it's not as pronounced. But you can see, you know what? Oh man. Okay, hold on. Let's go back to the complicated mesh. I think we can just shave off probably like the bottom little bit and get the same result. Okay. So we have this super complicated mesh. As you can see, it's like 16 FPS. It's not rendering. The ground isn't rendering. So this 16, 18 FPS is because our capsule is doing collision checking against all of the triangles in this mesh, which is 30,000 triangles. And you can turn on collision view, balance view, and you can see this super dense, complicated mesh. Now, if we switch over to the sphere, we get 60 FPS. We get 60 FPS. That's crazy, dude. We got 60. And the way that I'm doing it is basically we determine, and this still, you know, is probably slow, but this is not bad. This is like completely usable. The way that I did this, again, I'm not sure if this will work, but the way I did this was essentially saying, okay, if the distance between the sphere and the triangle center is greater than the maximum span of the triangle, then we couldn't possibly be close enough to collide. And so we just dip out. That's the concept. I just visualized it here. I just visualized it here in this little drawing where basically we say, well, if the distance between the sphere and the triangle is greater than if the distance between the sphere and the center of the triangle is greater than the maximum span, basically the distance between like this is a span, this is a span, and this is a span, which I obviously these two spans are the same, but like, because this is an equilateral triangle. Well, it's not equilateral, but maybe isosceles. These two are the same. Anyway, the idea is we don't have to check the triangle if we're nowhere near the triangle. Novice R says, are there ways to organize the collision mesh so you're looping over less triangles in the entire mesh for collision checks? Yes. I'm not going to do it, but I probably should be using BSP trees or oct trees or something like that to basically organize the collision mesh into some sort of set of cells, and then just check the triangles that are in the same cell, or cells in the same cell or neighboring cells as the collision checking object sphere. So it could just be like, you know, check these triangles instead of all of these triangles. That's basically what I'm doing with this, but really, yeah, I'll just say to do replace this with an actual oct tree or something. The triangles should be organized spatially. So I can to yeah, so this is a fine solution. It's not great, but it's perfectly usable. It seems to be perfectly usable to get the job done, which is great because like to go from well, let's see how long it actually took to collect. Let's see how long it took to do collision intersection testing for capsules versus spheres with the changes we just made. It's down here, yeah. Okay, so it's taking, yeah, like 20 to 40, kind of it ranges, but 20 to 40 milliseconds for capsules, and it's taking 4. Oh, that's insane. This is what's fun about making a renderer, dude. You get giant leaps in optimization like this. That's great. So it went from 20 to 50 milliseconds for capsules, which we haven't done anything for, compared to 4 to 8 milliseconds for spheres, which is great. It's looping through 30,000 triangles per frame. Yes, but it's only checking for collision on the ones that are nearby, basically. So that's still it's still not as optimized as it could be, but it's still like that's pretty good. That's completely usable. That's completely usable. Now we just need to do the same thing for capsules. There was an interesting problem that I feel like I feel like there's some. Well, maybe I. Oh, okay. I was wondering why the capsule fell through the ground. I saved this. I pressed P. I didn't mean to actually save this. No, I didn't think about it. Can I go back? Thank you. I just realized I had the complicated version. I went like this. I pressed P selection. I exported. I think I exported like this, like from the exact half. But this one doesn't have the, it does have the triangle. It's weird. Okay, let's export this real quick. I want to see if because the capsule fell through the ground, but I didn't catch that. Yeah, it's falling through the ground. Falling through the ground. Let's delete this one. Carl says if you break up the ground, a lot of the triangles will get skipped, won't they? Yes, yes. Because it is segmented according to mesh, and we do have I do have checking via AAB or yeah AABB collision checking. So like when a sphere checks against a triangle mesh, it checks to see if it's basically intersecting with the AABB first, and then if so, it goes on to check all the triangles. So if you segment your really dense map out into 2 different sections, it's only really going to check the ones it's near or bordering. For the capsule check, what are you doing that makes it super slow? Could you do something involving spheres to make it faster? The capsule check is basically just a sphere check, but it just has to get the basically. Let's do it. As far as I understand it, a capsule is a line where you can say, I want to get a sphere somewhere on this line, right? So, visually it's represented like this. But mathematically, it's actually like, oh, I want to get the bottom of the capsule. So it's really just a sphere here. Or if you have a triangle here, for example, then it would be a sphere here. And then if you have a triangle here, then it would be a sphere here. So it's not actually like a physical object, it's just a line. You have to get the nearest point on the line to get the sphere, to get the internal sphere. So I can apply anything I do for spheres to capsules and vice versa. I just haven't done it for capsules yet. I haven't made this improvement, which seems to be good. However, I just noticed, or we just found out that the capsule is falling through the ground, which is not supposed to happen, and it hasn't happened until now. Also, I have to comment that out. Is it looping through 30,000 triangles per frame? Yeah. Just I answered that, I believe, but I just wanted to re-answer it. So yeah, I'm not sure why it's falling through the ground like that, because it definitely wasn't, or it definitely isn't. Yeah, it definitely isn't supposed to. It isn't supposed to? I don't know. It wasn't before. I haven't really seen a problem. So projecting onto the line and then do a sphere check. Yeah, exactly. It didn't go to the ground. Let's see. Wait, hold on. It might have been one of the changes I made to the sphere, to the capsule rather. Which is here. Maybe this is incorrect. I'm gonna copy this. You know what? I'm just gonna copy this entire thing. I'm a little paranoid. That was, yeah, that's the wrong one. Need to copy capsule. All right, so do that. Let me just roll back. Why is it so like absolute? Let's see. All right, so this is still there. Okay. We tried there we go. Okay, so yeah, we just don't want this. Or Capsule line dot dot capsule line. That's definitely, I should be able to. It definitely doesn't seem like that would be an issue, but let's see. Maybe that's the problem. No, it's still falling through the ground. So then what's going on? Okay, so it actually is. For some reason, it's only returning contact like late. Where to transform? Playing the top and bottom. Top that sub bottom. Distance is less than top bottom. Oh, this might. I think this feels like it should be that capsule line capsule bottom dot add line dot skip minus top minus. I guess that's right. I suppose that's right. Yeah, this feels weird. It's detecting as it falls through the ground, but only like once it reaches the halfway point, like bonk. I think it might be that it's only doing like half the distance it should be, half the length of the capsule. That might be the problem. But it wasn't doing this before, right? What changed? Like, this isn't an issue if we have a full map, but it is an issue if we have a partial map. That makes no sense. Like, this works fine, but once I cut off, not even the triangles that it's on, but just any, is it any triangles? Like that, why is that an issue? What changed? What's the difference? Oh, is it like... Alright, let's do an experiment. I think that what might be happening is that it might be, for whatever reason, mirroring the position of the capsule. Or maybe mirroring the position of the... Oh, this might be it. Yeah, it might be this. Maybe these two lines. I probably don't need to invert the top and bottom. Maybe I just need to invert the line. or something like that. We'll see if my theory is right, then maybe it will basically be a problem, or the capsule won't fall if it's like this, where we deleted this half. If it's inverted, then it would be standing over here, even though that doesn't make sense. No, it's falling. I don't know. Like, why would deleting vertices that don't concern it make it fall? And is it any vertices, or is it just some vertices? Yes, it's falling. Okay. Is it these vertices? We're gonna get there. We've come too far, and this is too hype. This is too pog. All right, now it's not falling. Like, at what point does it start to fall? You change some vectors to 3D instead of 4. Does it use that? That's possible. It might be this stuff. I hadn't thought of that. I'll see. You might be exactly spot on. It might be some wrong code of mine. Maybe I'll go back and just remove the changes I made on this, even though it did make an improvement. That's like a significant improvement. Like, just not messing with triangles when you're not close to them would be the obvious improvement. Like, that is the obvious smooth solution. But I mean, I guess if I want both, I should have both. Let's see. There's definitely something that's making it fall. Okay. I think it might be in this code. No, it's still there. Isn't this where it was starting to fall? Yeah. Okay, so it fell. Okay. So what I'm gonna do, I'm pretty sure the issue is this. It might be that the closest point is not on the plane. Let's say we had like just a larger vector. Does that influence it? No. Oh. Yeah, no. I accidentally took control of the sphere. The sphere doesn't change. Like, the sphere works. The sphere works completely reliably. So that implies that it's an issue with the capsule specifically. Okay, yeah, let's not mess with this. The issue has to be with the capsule. It has to be with the capsule. Is it perhaps because placement of vertices colliding on capsule bottom is interpreted as the path point of mesh plane colliding on initial render? I don't think so. I don't think it's an issue of, because the code to make the objects move in the demo is always the same. Like, it's always the same regardless of what object you're using. They all move the same. They all get up, or both, the capsule and the sphere, move the same. They both have objects, gravity applied the same. Translation vector, it's applied the same. So that shouldn't be the issue. The issue, I believe, is something else. Like, the sphere shouldn't just like work reliably when the capsule does not. But I think it might be that the capsule Be something like this. Closest capsule point, capsule top, closest capsule point, capsule bottom. This is the closest point on triangle. The closest capsule point. And then the closest sub capsule bottom. The sphere might be working because the sphere has a broader point of contact, more chance of vertices with plane and capsule bottom because more vertices are present there. No, that's a possibility, but the triangles are large. Like this is a triangle. Like it's not big. It's not small enough where the sphere's size would make a difference. You know what I mean? Like I'm pretty sure if we made the capsule bigger, it still would have the same problem. Like you could still fall through here or here if that was the issue. I'm pretty sure it still will be. Let's give it a shot just to help troubleshoot. But I'm pretty sure there's something with. Oh wait, actually, hold on. There we go. Pretty sure there's something with the code for the capsule specifically. Yeah, it's still happening. And like no matter where I place the capsule, it still happens. It's definitely slipping through. So I'm thinking that the issue is basically something to do with the code I have that calculates the position of the capsule. Still too small, make it huge. I don't think the issue is the size of the capsule. Regardless of the size of the capsule, this should be working. I'm gonna try that sub. What if it's using the wrong point, the wrong like half of the capsule? That did not solve anything. Even using the bottom, it's still falling. Also, I don't know why the camera is positioned so poorly. I mean, I know why I positioned it poorly, but like, I need to fix it. Let's see. We don't need to profile anymore. Camera, let's move it back by like an additional 5. Move it up by 4. Since our capsule's bigger now. Okay. Move it back by an additional 5. Up by an additional 2. So yeah, it feels like there's something not about the placement of the not about placement. Like it's definitively falling through. Why is it falling through? And why is it only falling through when that half of the map is destroyed? Let's go back to the bounds. This seems to be fine. Well, let's compare the code for sphere triangle, because it basically a capsule. We should be able to copy it. Well, maybe we can copy the. Why am I not copying the code? I genuinely don't know why I'm not copying the code for this. Let's see if we can just do that. Is this the original code for capsule? Looks like it is. Okay. We'll call this the whole. And we'll say BT capsule triangles. All right. So the idea here is that basically we just want to call BT sphere triangles, but position the internal sphere of the capsule where we need to. And that might be where the issue kind of came into play. But let's try this. We'll say the internal sphere. Try something like this. Zadex says, hello, welcome to the stream. It's still falling through. Why? The world position of the bottom of the bounding capsule. World position at add. Up dot scale. Down. Okay. Is that made with Sprite Tile, the 3D model? No, this is made in Blender. Okay, so the position is updating. BT sphere triangles. I mean, clearly, like, this is going to be nil, or null, rather, but, I just want to confirm. Yeah, nil. Okay, well, I don't know why this... Sprite Tile is a Blender plugin. Oh, yeah. Well, I guess so. Yeah, that's true. But no, that's not what's going on here. Okay, so this explains a little bit. So not intersecting. Why would the sphere not be intersecting the bounding AABB of the triangle? Dash. Where's that AABB, buddy? No. No. I'm on to this. I'm getting there. So it's not intersecting the AABB. Let's say we didn't do this. Would it work if we didn't try to optimize away the AABB? No. Okay. Well then. Okay, so then maybe there's something else. So rather than assuming that the AABB is in the wrong place, maybe the sphere is in the wrong place. Why would the sphere be in the wrong location? I don't know. World position, world radius. Distance, okay. Wait, do I have other things in? Yeah, I do. Let's see if we can clean this up a little bit. when this works, we're gonna be pogging. I already said it once, and I'm saying it again for comedic effect. Sphere position distance. Okay. Okay. Sphere position, distance, radius. Sphere position was going down. Distance, okay. Radius. So it's 1.1 is the distance. Radius is 0.9. Closest point. Okay, well that's part of the problem. The box doesn't surround the mesh. We're assuming it's dead center, but that may not be the case. So all right, here's what we're gonna do. Debugging always helps in situations like this. So we're gonna go to the camera. When we go to draw bounding AABB, or no, bounding triangles, we are going to, and we have color, right? Yeah. So we're gonna say we want to firstly draw the, I guess we can draw it after. We're going to draw the mesh, but then we're also going to draw excuse me, bounds dot bounding AABB using the color. So this should allow us to see where the AABB for the triangle mesh is in space, which I believe the issue might be partially that it's not where is it? Am I crazy? Am I crazy? Or is it just not drawn? Or is it not there? The cylinder on one half of the ground plane. The sphere, which is not falling through, is on the other half. The sphere is just not falling because it's like dead center. It's like on the tip, on the edge. If we move it. Wait. Yeah. I'm not sure why it's weird. Like it's going. I don't know. The cylinder was working before splitting the plane into two halves anyway. The cylinder was working before splitting the plane into two halves. The cylinder, as far as I know, still does work if the plane is not split into two halves. But when it is, it stops working, which is weird. It's just weird. How is this drawing the? Oh, this is the mesh. This is the bounds. Where's the? This, okay. I'm like, what's going on? This is what I'm looking for. Okay, so it's still not drawing the AABB. It's strange. That's not drawn. Strange. Yeah, this is bounce. Okay. There's something going on here. All right, so it is drawing. Node internal size. Size. Okay, so it's 100 by 0 by 50. That's... Hold on. No, that couldn't be it, could it? Actually, CPU. I'm wondering if draw debug bounds 4. Yo, I guess if it's just a, it just okay. All right, so what we want to do is we want to make sure that I think what we want to do is we want to make sure that if either width, height, or depth is 0, it's at least like some number, because otherwise you can't intersect with it. I think that's part of the problem. That's not all of the problem, but that's part of the problem. That explains why it works until we delete this line, and then it magically stops working. So we'll do that. We'll export it, test it. Why is it working now? Is this not the same situation I've been testing for the past like several minutes? Okay, I'm going to assume that this is still the issue. If width is less than or equal to 0, we'll just say more. All right, that might help a little bit. Just a smidge. I'm not sure why it's working now. It was exactly like dead center where the sphere was on the edge. I remember that like specifically, but whatever. We'll try it again. Delete those vertices. Delete all the other stuff. Export this. If I can't get it to reproduce, then I'll just worry about it another time, because I don't need to be stuck on this. All right. Yeah, I don't know. I don't know, man. It's jank. I'm not gonna lie. It's jank. It's jank. It's jank. Jank things are jank sometimes. But hey, the upside is we should be able to kind of work with this a little bit better. Now, let's go back to the sphere capsule. Wait, capsule triangles. and get this back up and running, because basically this is what we want as opposed to all of this stuff, because a capsule is just, once again, a line and there's a triangle on it, or a sphere on it. So we will try this again. The ideal is to be able to, you know, be on the ground as the capsule and then be able to also bonk your head on a triangle, which we should be able to do by just like doing something like that. Oh, actually, can we get a vertex color? All right, so we'll export this. Okay. All right, so everything's good. Yeah, so it's not working as it should not be working, I believe, because we're using just the bottom. What we want to do is get the closest, that's why I couldn't do it this way, because we want to get the closest position on the capsule to each triangle. That's why I ended up making it myself, which is unfortunate and annoying, because I would have, you know, wanted to not have to do it. But it's just not, hold on. There we go. It's not, like economically feasible to do this, another way. So we'll go back. Fog outside. We'll go back. That might have been the issue part of it, honestly. Could have been. We'll see. Inverted. Okay. Transform no low. Capsule radius. Zero crossing. You'll see. What we want to do. Oh, that is not good. Yeah, that's definitely not good. Yeah, it's jank. Once again, it's jank. Yeah, that is definitely still jank. Okay. All right, so what I'm going to do. Oh yeah, that's part. Yeah, that's actually probably. Now that I think about it, that's probably part of the issue as well. Okay. All right. So here's what I'm gonna do. I'm gonna do what I did for the sphere, which is just copy this code here and just put it here. Then I'm going to never speak of this again. Okay, so that should kind of get us to the point where we should be able to kind of get going. The general idea here is we will simply never, the solution is to simply never speak of this again. All right, let's see how much time we're taking here without that optimization. So we're taking on the order of a millisecond. 1 millisecond, half a millisecond, somewhere in that range. With the optimization, we're taking considerably less, like a third the amount of time, which is good. That's really good. 300, 300. Yeah, so that's good. Take that out. Okay, so with this, we should be able to do this kind of only check objects within range. We could do that as well. Yeah. Yeah, that's true. That would be a good optimization as well. But I'm kind of tired. So what we're gonna do, we're just going to make a function. I'm trying to think of how I want to do this. We're gonna do something like this: resolve collisions. And this might be enough to kind of get us going where we want to go. Yeah, so that's the general idea. Oh my god. Oh no. Oh no. Oh, this is so stupid. Alright, so that didn't work. It might have been actually it does kind of not work. But I guess it's because there's no wall to the ramp. Yeah. So I guess it's kind of to be expected. It's kind of like a zip in a 2D game where you kind of get into a space. That's fine. There should be a wall. All right, I think that's fine. I think that's fine. But let's go back to our actual game. It's been eons since we actually ran this. But let's see what we're looking at. All right, no bonks, no bumping. Can go up and down the stairs pretty well. He slides down, but that's not really that big of a deal. All right, that's good. That's passable. That's passable. Also, I should do something about that to not be so ugly. I just want to see one last time. What are we looking at in terms of intersection? That's pretty good. It's better. Sub 1 millisecond is not bad. So what I'm going to do to end this off is probably make some sort of system that allows us to tell what objects have been intersecting with which objects, and it just stores those intersections. That way we don't have to check multiple times, unless we need to check multiple times. Wait. Yo, why is it not bumping anymore? What did we do? What? I mean, he still bumps in the corner, but like it's not bumping anymore. It used to bump. It used to bump. The solution that I had was to basically move the character down for gravity, then check for collision and resolve it. Oh, it was this. Okay, this is what we did. Okay, that's right. That's what I did. That's why. Okay, yeah. That kind of fixes it a little bit, I suppose. Capsule, NPC checker. Yeah. Here's what we're gonna do. We will make a thing. It will be collision. It will be a map of game object to Tetra3D bounding object. Actually, canceling the velocity in that direction at the end would work too, I think. Yeah, I feel like it's one of those things where I gotta like take a look later on and like see how I want to do it, because it definitely feels like it's not a great solution, but it works. But at the same time, like there should be something better. I should be able to come up with something better. All right, so we just do this. All right, so we get the bounding objects. Then we say for B in range that bound objects. A if A dot intersecting then let's do this. I'd like to do this a different way. Maybe like you subscribe an object, and then you can tell when it collides. Like you say, I would like to know when A collides with anything, but you also add B, C, and D to the collision system. Then you can check, like it will let you know when A collides with B, but it won't like let B know that B collides with A. It doesn't need to know that information. Does that make sense? That's over engineering, isn't it? How would I like this to work? I would like to know if I would like to have something like this. If player.scene.collided that returns maybe an object. Excuse me. So it would be this nitrogen nil. So collided with something. An NPC checker here is a bounding sphere. So if the bounding object collided with anything that has this tag, then it would probably be a slice, right? Because it could collide with multiple objects at the same time. Something like that. Zero C says, I gotta go, but I have to say I really like your work. I'm glad to find you through Masterplan on the Steam sale. Keep up the great work. I'll be following along at your Patreon. Yo, thank you very much. Yeah, I really do appreciate it. And thank you for stopping by and watching the stream. It's tough, but it's been fun, and we got some pog moments. We got some great moments. So I'm happy with how everything's working out, even if it's weird. So I'm thinking I like this design because it's relatively simple. So we have to kind of know this, like the scene has to kind of like grab this information or get this information ahead of time. Yeah, really, we just don't want to have to do this ourselves. We want to kind of leave it to something centralized to do it. So we know if there's bounding objects. We see if A is colliding with B. So collision could just be... Let's do this. Because for the most part, if you collide with any one thing, that's probably enough. So we'll just have we'll have this system. Good luck. Oh, thank you. Thank you very much. Collisions A equals a pin, collisions A, B. All right, so that's that. Technically we should, yeah. And that's the thing too, like we don't really need to know if A collides with, we need to know if A collides with B. We don't need to know if B collides with A because that's the same information. But, so yeah, we really don't need to know that actually. If A collides with B, should we take B out of the list? We should. Shouldn't we? Let's make this simpler through the process of over engineering. Oh, start. Object. Okay, so something like this could kind of help us out there. So basically you loop through oh, this is wrong. You loop through every bounding object. So this, we still need to loop through both because we need to do a collision check for both. But once we started going through, like once you go through A, like once A collides with B, you don't need B to collide with A. You need to remove B from the list, but we're looping through it. I don't know if can we alter a list a slice while we're looping through it? I don't know if we can. Maybe we can. Maybe we just don't have to. We can't use a range. So let's see. Well, we already. Oh yeah. Okay. So for that bounding, really we could just say like we don't need to maintain this. All right, so something like this should kind of work. And bound slice is greater than 0. Okay, so now we can loop through. Okay, A is bound slice 0. And we can also remove one from bound slice thusly. We're popping off the list. And we can do the same thing with B, because if A collides with B, we don't need B to collide with A. So we can just remove it from the list too. No, wait. I feel like I'm on the right track though here. I guess it's impossible for A to be B, right? Because you're popping one off the list, off the front. B is going to be 1, 2, 3, 4, 5. Then you move on to 2. It's going to be 3, 4, 5, 6, 7, like that. Okay, so then this will never be true. Then so wait, yeah, A, B, C, D. So you check A against B, C, and D. Then you check B against C and D. Yeah, so A, B, A, C, A, D, A, E, B, C, B, D, B, E, C, D, C, E. Because C and B have already been checked. B and A have already been checked. All right, so that works. Cool. So this should work. And then this would be a map of... This, I guess we could just make this collision pairless for simplicity. There you go. Collision pair slice rather. Like that, and then we say collisions, pin, C, collisions, new collision pair, A, B. There we go. Then, yeah, that's fine. And then we can basically say, collision pair, bounding object pair for P range scene dot collision pairs if P dot contains obj return P. Okay. All right, so this contains other obj cp.a return cp.b also return cp.a okay, so this is an idea. Let's see if this works. So first, we're gonna try this first with well, we'll just do this first. If player dot, this won't work. This won't work because the player needs to check the ground basically immediately. Maybe we should do this another way. What if we registered objects? So we say the player and the ground, they're a pair already. How does that help? if you register them as a pair, then that doesn't help. That doesn't help. Well, but we already know that they're colliding. We already know. Well, okay, so like the player, capsule, and every other bounds object in the game should be a pair so that he can walk around and bump into stuff. Then we could say for the other, check for the intersection. All right, let's go with that. Let's go with that. So you're registering pairs. So that would be the player. That would be a map of Tetra3D that bound the object to a slice of bounding objects. That's what I had before. New collision slot system. Register. I don't know what to think quite, because I'm wondering what's the point of registering. Well, I guess the point is not every object needs to register with every other object, right? So we don't need to check for collision between the, well, I mean, that's not even a problem. We just want to avoid looping through and checking for intersection between objects that we don't need to check for intersection by. But really, I guess this is the same loop, really. Like, this is the exact same thing. It's just this. Like that is this is just what we want to. All right, let's just start with this. Let's start with this. As absurdly complicated as that was, or just over-engineered / annoying as it was to watch, I'm sure. Not that far. Okay, so this is what we have. Yeah, it's no good. Let's see. That's where this goes. That goes. Okay. So something like this should kind of get us where we want to go. All right. All right, that kind of works. That kind of works. Character needs to be a little bit higher off the ground, but this is basically where we want to be. All right, yeah, that's pretty good. That's pretty good. We will. How do we want to do this? I guess, let me see. Where's the player? Hog says this looks sick. Yo, thanks. I'm, for whatever reason, doing everything myself, like an imbecile. We can How do we have this? We got the cube, we got the armature, we got the shadow. We really just want to move everything up a little bit, so I guess we'll just move everything up a little bit. I think that should work. Let's export this. Is the shadow where it should be on the ground? Yes, kind of. It's better, so that means that it did work. It's just we didn't move it up enough. Let's move it up like here to... Yeah, that's fine. I mean, like if he's floating, it's the perspective is heavy enough, overhead enough where I don't think people will notice, or I would notice if I wasn't paying attention. Okay. All right, so we're getting there. We're getting there. It's slow but sure. I'd like to see what's our time like here. One more time. We can actually skip this around a little bit and say intersect object. Oh, we might want to bump into it. Okay, that kind of helps out a little bit more. Yeah, that helps out a little bit more. It's come a long way. Yeah, I think it's getting there. Thank you for your encouragement, everybody. Let me actually. What's our time looking like? And I should just like leave this. I should just leave it basically printing, but. All right, so intersections taking about a millisecond. 1 to 1.5. That's an honest. There's some outliers here and there, but for the most part, it's 1 or below, which is not bad. That's not bad. Let's see. Is it the capsule that's taking the most time? I imagine so, but let's see. Ooh. Wow, really? The capsule takes that much time? Capsule intersection? No way, dude. That's incredibly slow. Okay, we gotta fix that. We simply must. Why is it taking so long? That programmer Tom says, long time no see. Hello. Welcome to the stream again. I've been going for like 4 hours. 3.5. But this is, I'm on the line, man. I'm on the line. Same as with the sphere. You can pre-calculate the size of an object and just skip whole objects that are too far away and triangles. Yeah, that probably would be good. I am doing this, right? Yeah, okay. That's squared. I mean, did this actually like make a difference for the capsule? Doesn't feel like it really did that much. Am I still working on Iquia? No, I'm working on something else actually. I'm working on a 3D renderer. Probably easy to speed up. Yeah, I guess it is a speed up. I guess it did speed things up, yeah. Yeah, it went from like 1 to 2 to like 800 to 1.5 roughly. That's definitely better, but it feels like it should be faster. Can we avoid? I guess we could probably just do this, huh? Spread. Yeah, actually, now that I think about it, going back here, it should be probably this plus the sphere radius. I forgot to add that in. Only half watching and half working, so if I missed something, my apologies. Oh yeah, no problem. No problem at all. Is it the inverted transform? That doesn't sound right. Let's see. Yep. But yeah, I feel like in the sphere, wasn't it inverted no transform no look? No? Okay, we're good. Alright, so let's try that. That might help us out a little bit. It's your stream. You can always tell the armchair programmers to shut it. No, I'm happy to have suggestions, especially when I relatively, yeah, I am not like that good. There's many things I need to improve upon. So it's faster. It's definitely, well, I don't think this actually made that much of a difference. This as opposed to putting this here. I'll leave it cap spread. That's fine. Magnitude. Okay, I think this is probably where we're losing a lot of time. I've known SolarLune even before Goran was around. I need to be more active on the streams. Yeah, it's been, wow, that's years ago, man. Goran Milovanovic, if I recall his name, was the creator of BDX. He's a very good programmer. That's the past, man. That's memories. So I feel like if we can avoid doing this, that'd be great, but I don't think we can. Never mind. We totally can, because this, oh no, closest. Yeah, closest point on triangle. So this, yeah, definitely, oh. Yeah, we can definitely do this. And then at scale. Yeah, this is largely, like, there's not much you can do about that. Delta is fast vector sub, yeah. It's less than capsule radius, yeah. That's about it. Oh, this is the wrong one. Yeah, I'm not sure why it takes so much longer for capsules compared to spheres. I mean, I know why, but like, why? Like, if we just said, hey, let's make the capsule instead a bounding sphere. With, yeah, if we made it a bounding sphere, it goes from 800. Well, it's not that big of a difference, I guess. It's a difference, but not a massive one. Yeah, so I guess we'll just let's go back to maps. I guess we might just end up splitting this up a little bit, which is probably good because at some stage we're gonna want to seems like a good-ish spot to split this up. At some stage we're gonna probably want to like, there we go. Some stage we're probably gonna want to like do this so that we can easily make the rooms without having to like manually, you know, model the entire thing. We can just kind of like put pieces together, and that probably would be good. Let's see how much time it takes this time. I about that. Okay. better. Sub one millisecond. That's crazy. So yeah, we do need to just segment stuff more. All right, well there you go. Yeah, distance checks are probably a good idea. But hey, this is pretty good. Sub way under 1 millisecond, actually averaging 300 picoseconds. No, microseconds. I think microseconds. Picoseconds are the next smallest, like thousandth integer. I think so. This is hundreds of microseconds. That's pretty good. When did I start coding Go? Paul asks. I started coding Go. I don't even know. I've been coding in Go for a while now. This is pretty good. This is actually like, it's not bad. This is not bad. All right. Okay. All right. We're doing something cool here. We're doing something cool. Yeah, I've been coding Go for like a while. A couple years at this point, maybe 2 or 3 years. Three or since before 2020. Yeah, so maybe like since 2019, 2018, 18, 19, or 19, 20, 21. Yeah, so I'm like on my 4th year of like pretty considerable Go usage, I suppose. I was like making things like Resolve and which is a collision library, like a collision checking testing library for 2D games. LDTK Go, which is a parser for LDTK files for Golang. So I've been working in Golang rather for a while, but I've been kind of more serious about it recently. And it's going pretty well. I like it. Never used Go until my current job. I fell in love with it. I think it's a great language. Yeah, I think it works really well. It does what it's supposed to do very well. Yeah. So this is pretty good. This is honestly not bad. It's solid. You know, I mean, for this to be a 3D renderer that I made myself, I'm pretty happy with it. You know, definitely feels like a PlayStation game, and it's something else to like try different things, and I think that's the thing that I like the most. The thing why am I doing this? I think that's the thing I like a lot about working on Tetra, is like you walk in and you're working on your game and it's like, man, this is, you know, it's so slow, or this isn't working so well, or whatever, and then you make some changes and now it's 200% faster. Now it's 300% faster because I coded it poorly in the first place, really. So that's fun. Like it's a lot of fun to be like, oh, this is better. This is feasible now. That's possible. Snow says, will we be able to use shaders eventually in Tetra? Yes. The current design is, the current idea is basically for 3D vertex shaders, because vertices don't exist in Ebiton in the traditional sense. Like there's no 3D vertices. They're just, things in 3D in Tetra are just triangles, 2D triangles being drawn to indicate depth and to give the feeling of 3 dimensions. So vertex shaders are basically just functions that run on the vertices on the CPU. So for example, in this example, it hasn't been finalized yet, but you can say for a specific material, which is the player's material, we can specify a function that runs on in the clip space, or in clip space, that takes a vector of the vertex position and then returns a vector, which is the modulated vertex position. So in this example, it's basically rounding off the clip position of the vertices for the player's material, and the end result is this. Actually, let's do something a little bit smaller. There we go. The end result is this effect that's very interesting. So he's kind of like locked to a grid, but only his rendering, like his actual 3D mesh is still there, and he's animating just like he normally would, but his rendering is just different. The clip space is different. And so that's how like Vertex and clip space programs would run, basically like this. And then for color, like fragment shaders, that's going to be actually a fragment shader that you can specify with Kage. So it will basically run on the color texture, on the color result that gets rendered. That's the idea. So I haven't implemented it. It should be basically simple, but I haven't like really gone too deep into it. This is such a weird effect. Did you ever try that with everything magnified to lessen the effect? I'm not sure what you mean. With everything magnified? Magnified. Everything. Everything magnified. Yeah, I'm not sure what you mean. I'm not sure if you mean like with everything big, multiply everything so the rounding is smaller. Oh, yeah. I mean, yeah. I could have like a smaller rounding for it, but I want it to be big. Oh, I mean like, yeah, there we go. You could have a smaller rounding, but I want it to be big for a specific. If I were going to use this, I would use it for a specific purpose, and it would be very noticeable. But if you want like a really small, round off, you can definitely do that, and it gives the effect of like a PlayStation 1. How the things are kind of like rendering is locked to a grid, and so you can apply this to all of the materials and all of the objects in your game if you wanted to like make it look more like PlayStation. But yeah, the answer is yes. There will be shaders, and the design is a little weird, but the upside is relatively simple to use. Like the downside is it's not going to be operating on the GPU, so it's not going to be like performant or as performant as it could be. But the upside is it, for one thing, doesn't rely on like it actually is in 3D space, so you can more kind of easily like move vertices around or refer to variables that exist outside of the clip program if you wanted to like get data from an external service or bring in more information than just stuff that you can pass directly to the GPU under normal means. Lucretius, my boy, Solar is still going, you monster. That's correct. I'm gonna be heading off soon because I'm tired and my throat is kind of sore from talking a lot. But the upside is we managed to get some like cool stuff going. Collision checking is working better for capsules and spheres. It's been optimized considerably, which is great. There's still a lot of ways to optimize, I believe. Yeah, this is like it's like 300 picoseconds or 300 microseconds rather. I think that's right. For collision so far, which is good. That's pretty good. And also it's like 1 millisecond, 1.4 for rendering, which is not bad. Snow asks, Tetra supports all the platforms that Ebi 10 would, right? Yes. As long as, as far as I know, yes. Because the only thing I'm doing is just modifying numbers. So like if you're working on a, some sort of weird platform that maybe doesn't support float 64s, that kind of thing might be why it wouldn't work. But if you're just like, oh yeah, I'm like working on Windows 64-bit or Linux or Mac, it should definitely work just like anything else in Ebi 10. That's the upside of a software renderer, or kind of software renderer. Go is very cool and fast. It looks like a scripting language, so it really throws me off on its performance. Yeah, it's interesting. It's been interesting to kind of be like, on the one hand, things are really slow, and then you make some improvements, and it's suddenly just extremely fast. And it's like, oh, so it's just me. So it's just me sucking. That's basically that's the problem. I suck at writing code correctly the first time. But I think that's fine, to write code poorly the first time. But it's fun to be able to optimize the language, optimize your algorithms and things to be faster. I could release for Nintendo Switch. Yeah, that's possible. I don't know if it would run fast enough, but Hajime said that, you know, he did some work with like actually natively compiling for the Switch, and it worked out. He was able to make his game and put it on the Switch. So it's possible maybe this will run fast. I don't know. I haven't tried on mobile devices. I'd like to try it. If I could get this running at 60 FPS on a phone or something, or even like, you know, faster, that would be fantastic, dude. I have no idea if this would run fast, but it's surprising because somebody ran the stress test that I made for Tetra in a web browser, and I was getting like 30 FPS, which is really good in my opinion for like 30,000 triangles. Like that's solid. Like that's, you know, to be a web, you know, to be a game or demo running in a web context and be getting like playable FPS on a software-ish renderer, on a renderer that, you know, is doing math or transforming the vertices on the CPU. It's like, yo, this is actually fine. It's kind of funny. 30 FPS is very good on web. Yeah, I've played a lot of, or seen a lot of things on web where it's like, oh, it's supposed to be like a super cool shader or something on like Shader Toy, and then you run it and it's just like, it's extremely slow. And it's like, you know, I'm not blaming anybody. It's just, that's just what it is. That's just web right now. And it's very interesting. It's very interesting to just have, you know, it's interesting to have something that like is running pretty well on web, because it's like, I know this is super slow. Before GPU, everything was done on the CPU, so you're all good. Yeah, I still have to do multi-threading. I still have to figure out how I'm gonna do multi-threading. If I could do multi-threading, that would help out a lot when it comes to frame time. That could drop it down considerably, I think. But I still have to approach that. But yeah, this is pretty good. This is pretty good. I'm pretty happy with this. We made a lot of progress, and yeah, it's been interesting to like try to build things and like, you know, kind of design how the game would work in terms of systems, because it's been kind of like questionable. Like, how am I going to do this, or how would this work? But it's not that hard. Snow says, doesn't Ebiton run a few things on GPU? Yeah, drawing the triangles, that takes the GPU. Rendering with the shader, that takes, you know, of course, the GPU. So like rendering the depth texture, drawing the triangles, that's on the GPU, but the vertex transformations, that's on the CPU. Yeah, so like it's a hybrid. It's not a true software renderer. It does a lot of stuff in CPU to basically make it 3D, and then we're drawing to the screen using GPU accelerated triangle, draw triangles calls. That kind of is like what makes it possible. If this was an actual software renderer that didn't have the GPU, this wouldn't be running probably. I don't think this would probably be like 1-2 FPS, because it's just like there's no way I could probably draw the triangles, like you know, fill the pixels to actually form the triangles. I don't think it would be fast enough. I don't think. But yeah, this is good. This is solid. This is totally playable. All right, well, I'm kind of dead. It's been fun. I'll have to catch you guys on the flip side next time. And hopefully we'll be able to keep working with the Ebiton, or with Tetra3D and Ebiton, and make something cool. I want to make like actual progress on this example game. I want to actually have something completable that people can, you know, play and have fun with. Yeah, if you want to support development, please check out the Patreon, Itch, Steam pages in the description below this video. And otherwise, I'll catch you guys on the flip side next time with more content. See ya. Also, a master plan. A master plan is a lot of fun. It's a cool program to use. It's a project planner of mine, and I'm working on it as well. So hopefully a new
update will be out for that soon, because it's been like a month since the last one because of a variety of things. So sorry, it'll be coming out soon though. And thank you very much for watching. I'll see you later. Bye.